We're going to take a second here to go over the LoEx foam estimator tool that we've added to our digital tools section. So we're going to go ahead and just hover over digital on our home page. And we're going to see right here where it says LoEx estimator. Now this tool is going to be used for low expansion foam systems. You'll see just above it we have a tool for high expansion foam systems. That being said, we're going to go ahead and click on low expansion. And that'll take us to a disclaimer. And take a second, read through that, and then we'll accept it to be able to move forward. Um, and once we get that out of the way, we see that we have two options here at the top of the page. We have a replacing an existing system or ordering a new system. Now, ordering a new system is going to be used quite a bit, but right now there's a transition process with legacy foam concentrates like AFFF to transition into new synthetic fluorine-free foam. Now, if you have an existing system and you need information on that transition process, by selecting some of the information that's here. So if we had a wet system, so we're replacing an existing system, we've chosen wet. We have these different discharge devices here to choose from. We're going to say that it's a foam maker. Here is our storage method for our concentrates, bladder tank or atmospheric. We'll leave bladder tank populated here. And if we know anything about the existing design, so let's say maybe it's a 0.16 over, and we'll say 5,000 square feet. And we're currently using a 3% concentrate. And if we know the duration, it depends on the standard, but let's just say 10 minutes. And then we'll select our fuel. At that point, we can go ahead and put in any additional information. Maybe we want, please call SAP. And that note will come through on the system. And basically, we're going to hit finish. When we hit finished, we're going to put in our company information, our contact information, maybe a project that we're talking about. And we'll go ahead and hit submit. And when we hit that submit button, that will generate an email. And that is where we'll get the information and we'll be able to reach back out and have a conversation about how to go about that transition process. So very simple, just a little data collection so that we can reach out and have that discussion. If we were going to order a new system, it's pretty straightforward here as well. It's a bunch of selections that need to be made. So we have NFPA 11, NFPA 30, and FM 7-29. NFPA 16 is out there, and it depends on the code version that you're using. But recently, NFPA 16 and 11 were merged together. So if you did want to put a system together in accordance with NFPA 16, maybe under an older code model, you would just select NFPA 11. So NFPA 30 and FM 7-29 are also choices that could be selected. Now, what we're going to do is we're going to work through this process. And what's important to understand, too, is that Viking is currently the only manufacturer with an alcohol-resistive concentrate that is approved for polar solvents and things, as well as hydrocarbons through FM. So FM 7-29, that's going to get used quite a bit here as well. But using NFPA 11, we'll go ahead and select, just for this purpose, we'll select hydrocarbons. And then we'll take a look at what type of system do we want to build. So let's say pre-action. It'll give us an overhead sprinkler system. Now, if you select NFPA 30 or NFPA 7-29, you'll see that you'll also get options for an overhead and in-rack in one riser, or an overhead and in-rack in a manifolded riser. So you basically have a main wet riser that would supply the overhead riser, and then an additional in-rack riser. So this option here really gives you 3 risers, if that makes sense. And this one would give you 1 riser. It combines the overhead and in-rack into the single riser. So we'll Well, we can leave it on NFPA 30 at this point. Doesn't really make too much of a difference here, but we'll select our fire sprinkler that we're going to use. And what's important about this is the fire sprinkler that we're going to use. In this case, I selected a K of 8 versus a K of 11.2. It really depends on the standard. That's going to drive the minimum K factor for the overhead. And why this is important is with the new synthetic fluorine-free foam, you have to select your fire sprinkler that you're going to use for your overhead so that we can get to a density. Now, quite often the density is outlined in the specific standard or document like FM 7-29. But that being said, with synthetic fluorine-free foam, some of the densities vary from what the documents indicate. So if the document has a lower density, you would default to our density, which may be higher. So whichever document or whichever one has the higher density, that's the one that you would want to go with. So in some situations, NFPA 30 and FM 7-29 as examples, their densities are lower than what we are approved at with the synthetic fluorine-free foam fire sprinklers. So that being said, this will figure out that density for you. You're just making the selections here, so you don't have to get too wrapped up about that, but it is something you want to verify. Now we're going to go standard response. So when I select standard response, it gives me a couple different options here from our standard response selection. So we have the VK200, the 2021, and the 204. So we'll go with 204 for now. And you'll see once I select that, it populates a density for us. So the VK204 for hydrocarbons is a 0.4 density. If I select isopropyl alcohol, then go back to my K factor and then standard response, the VK204 now, in this case remains a 0.4, but in certain situations, that's going to change. So if I select the 2021, we're going to have a 0.3 density that populates. And then the upright again at the VK200 is going back to a 0.4. Now I can increase my density. So if I have a situation where I want to bring that density up, I can basically just increase that here. But you'll notice you can't go any lower. And you can't go any lower with that density because the minimum density that's populated here is what this sprinkler was approved at. So here's another example. I have a 0.3 density here. I can't go any lower, but I could bring that up. So in certain situations, the density will be increased, and we have that ability to do it, but it will not let you go lower than what the approved density is for that particular sprinkler. Now, in this case, we're going to select an area. So that's going to come from the standard or the document that we're using to design our system. So in this case, I think we left off up here at the top with NFPA 30. So we're going to say we're going to use a 0.3 density over 3,000. And that's going to be through a K factor of 8. And that's going to tell us that our demand for that system is going to be 900 gallons per minute. This is our equation for figuring out our concentrate and tank sizing and riser sizing and everything. So we have that 900 gallon per minute demand, 3% concentrate. You'll notice there's no change in this because that concentrate percentage is a fixed number. It can't be altered. And then you have duration. So the minimum duration here is going to be populated by the standard. If you wanted to increase that, you definitely could. But again, you can't go any lower than what the minimum is for that. The safety factor here is 15%, which is pretty standard. If you wanted to lower the safety factor to 10 or what have you, it is possible. We recommend 15 as the safety factor, however. And that's going to tell us what our total concentrate value is. So at this point, a 0.3 density over 3,000 square feet is a 900 gallon demand. Our 900 gallon demand, 3% concentrate for 15 minutes with a 15% safety factor is going to tell us that we need 465, or we could just say 466 gallons of foam concentrate. Now that foam concentrate would go into a bladder tank, so that's our next option. Horizontal is selected currently. We can select vertical, and that bladder tank will be sized, and that bladder tank will be sized at 500 gallons for that concentrate to go in there at 466 gallons of concentrate. I have some options here that I can choose from if I want domestic trim, and do I want hose connections? Now, the hose connections are basically for the solution testing um, test header here. So it looks a lot like a fire pump test head would look. And basically what we're dealing with that is you're using that to test the solution, which you want to determine whether or not the solution has been proportioned or the concentrate has been proportioned correctly to make the solution. So this is where we do it. We get our water flowing, we get our system flowing at its full demand, and then we take samples to see if we're within the correct percentage for that testing. Now these connections are sized just like a fire pump test header, 250 gallons per minute of the system demand. So in this case, we have a 900 gallon demand. So we're going to have 4 valves that would be included in this. Now, if I had a deluge system or pre-action, I could populate with a release control panel, and then that would get us that ability here. But we're at wet, so we don't have that release control panel right here. But if we wanted that release control panel, that would be an option for us to select from. So we'll go ahead and hit the finish button here. And once we hit that finish button, we can put in our contact information again, very similar to how we had it before with project name if we want to add that. And what will happen is it will provide a list of parts for the bill of materials. And you'll have this in an email. It also comes to Viking here, the team here at Viking. And what will happen from there is you will get a quote generated from your list of materials, and it will be sent to your email here in the information. So you want to make sure that that email is correct. So that being said, it's very simple to do. And the information is easy to work with, and we will look forward to you exploring the tool and working with you for your next low expansion foam system. Thanks.